All right. I just turned on recording and I'm excited to welcome you today, myself and my co-host, Bhavik Patel. We are using this to kick off what we hope will be a regular recurring webinar series over the next few months with speakers from around the globe talking about innovations in their analytical chemistry teaching and in education. I want to quickly just share our next speaker will be on Friday, May 30th, and it's Dr. Patrick Thompson from the University of Strathclyde in Scotland, who will be speaking about precise, accurate, or accessible affordability in analytical chemistry outreach and teaching. And I'll put the link for that in the chat as well, because that might be easier to use than the QR code if you're sitting at your computer. So we hope that we'll see many of you again at our next seminar. We're planning to do these on the last Friday of the month for the next few months, and we have speakers lined up as well from Peru and South Africa. And so we're really excited that Chuck is kicking this off. Bhavik, I don't know if there's anything you want to add to that.
I think that's a perfect introduction. Welcome, everyone. And yeah, we look forward to seeing you all at subsequent webinars where we learn a lot about exciting developments in analytical chemistry education research.
So we were kicking this off and thinking about who would be a good person to do the first talk, who would attract a big crowd, and Chuck came to mind immediately. So our first speaker, Chuck Lucy, is emeritus faculty from the University of Alberta, but is very widely known, not just in Canada or North America, but I think all around the world now as somebody who's really been an innovator in analytical chemistry education for a long time. And now I think is really driving the way we think about the curriculum, because he is now collaborating with Dan Harris on quantitative chemical analysis going into the next edition, and thinking about how do we update the things that we teach our students and the ways that we teach our students. And that's what he's going to speak about today. So welcome, Chuck, and take it away whenever you're ready.
Yeah, thank you. I've put a link into the chat, which has now, oops, are you seeing the slideshow or just, there we go, okay. I put a link into the chat that has this talk and then a number of resources, and I'll mention what those are as we go through. Thanks all for coming. What I want to talk about today is sort of trying to take a very broad view of how we teach analytical chemistry, not so much the content, although I'm going to refer to the content quite often. When we talk about teaching or learning rather, the classic way to think of it is Bloom's taxonomy, which talks about the cognitive domain, the psychomotor domain, and the affective domain. And I want to touch on all of those. Maybe simply put, cognitive domain is simply often viewed as knowledge. Psychomotive domain can be colloquialized as skills, and affective domain is your attitude towards the subject. And we'll touch on all of those with regard to analytical chemistry. Now, full disclosure, and for Michelle, this is the cover for the 11th edition that's just about to come out. All of the examples I'm going to give are from the latest edition of Quantitative Chemical Analysis, because really the strategies that I've been thinking about to enhance cognitive domain, enhance psychomotive learning, and to enhance affective learning have all permeated into those revisions to the book. I often say you're going to find nothing's changed and everything's changed when you look at a new edition. So as much as possible, we have not changed section numbers or changed problem numbers, so you're hopefully not going to find too many disruptions of that way. But we've tried to add a different content, as I say, to attack some of these domains and to update some of the material. So when we think of cognitive domain, the knee-jerk tends to be to think about content. And I don't want to spend a lot of time talking about content revisions to the textbook. There are a lot of different things. This is just a subsection. Bring in concepts like trueness, green analytical chemistry and sample prep, a lot more about ligand binding assays and immunoassays and their calibration curves, competitive immunoassays, sampling methods, including headspace, screen printed electrodes, paper microlithography, molecular beacons, new section on Raman, and more. So that's pretty much all I'm going to say about content. If you're interested in content, I refer you to another symposia, or well, actually more of a discussion that's going to go on that's organized by the ACS Division of Analytical Chemistry about what our analytical chemistry students need to know. So each of the slides that, if you've downloaded, each of the slides have some notes that sometimes have references, sometimes have additional explanation. In that case, there's the link, which is also at the top of this slide. So I refer you to that for really, if you're interested in specific ideas about content. And that is meant to be a discussion session. So you also get to meet colleagues. So really, when we talk about Bloom's taxonomy and the cognitive domain, these are the type of pyramids you often see where the base is kind of the lowest level of learning, remembering. Then there's understanding, then there's applying, then there's analyzing, and we're getting higher and higher up into cognitive domains, and that is deeper and deeper learning. So to the end, we're getting to evaluating, creating in the cognitive domain. So a great resource in terms of enhancing cognitive domain learning is using active learning. And Michelle was a co-editor of this great monograph in 2022. So I really recommend there's a variety of different strategies to engage higher end learning in the cognitive domain and somewhat in the psychomotor domain too. Also, Macmillan has not been idle in this venue as well. They really have been working on enhancing their homework system, making it more Socratic, so that you'll now hear about AI tutor. And this is something that you can look at in the online Achieve system to enhance that cognitive domain. One of the strategies I want to talk about today is use of simulators. And that's something we've tried to integrate into the 11th edition, more so than the 10th edition. There's a variety of different great resources or repositories for simulators. And so these are three of them. The FETS, which we use in a few cases, the Analytical Sciences Digital Library. Every talk I give in analytical education, I always have to give the ASDL great praise. It's a really strong resource if you're not familiar with it. Then Chem Collectives is another resource. I have not worked with that one as much, but there is different materials within that. In terms of the quantitative chemical analysis, some of the type of simulators you'll see, we've got some interactive spreadsheets that are meant to help students work through titrations, and these are based on the sections we already had on titration on how to do simulations or spreadsheets on titrations. There's FETs such as black body radiation that are discussed in the section. Chromatography, if you're familiar with 10th edition, we used the HPLC teaching assistant for both basic chromatography and also for HPLC. And in the 10th edition, we'd used Pro-EZGC, which is a very powerful gas chromatography modeler, to simulate some of the behavior that we use in the figures. And I point out Pro-EZGC in particular because it's really too complicated to throw at students, unless you're doing a simulated lab. Students would really need 3 hours to really understand it and be able to use it. And that comes to something that I hadn't known about when I was involved with the ASD or ACS monograph on active learning, in that one of the ways to use simulators isn't necessarily what you would think. I always thought of it heavily for my upper level courses having guided inquiry or discovery-based learning. And so students would have to use the simulator themselves. This paper from Chemical Education Research and Practice 3 years ago now really was a revelation for me. And this used a FET program on just reactions and rates. And that's not really relevant. What was relevant was what they tried to do, in that they found, maybe the core conclusion is that using the simulation improved understanding of core ideas and understanding equilibrium. So right there, great, that's wonderful. The interesting thing I found was that the guided inquiry activity versus what they called a screencast, which was essentially the professor demoing the particular behavior with the PhET, and then asking students to discuss or debate different, what do you predict this behavior will be next? And both of those showed similar gains. Now, what is important about that is that tells you that you can take away some of the cognitive load of the students of having to learn a simulator. Because often when you survey students after using simulations, a lot of their effort was figuring out the simulator as opposed to the behavior. So this is a way you can short circuit that confusion regarding how to run the simulator and actually get right to the behavior that you're wanting to illustrate and have them really think about. And so that opens up the opportunity to use some of the simulators like the Pro EasyGC, which, as I say, is a heavy cognitive load for students. And so keeping that in mind, I think really made me reflect on how I'd used simulators in the past, which actually was somewhat in that manner in lower level courses. So keep that in mind. Okay, now, so we've gone from remembering to understanding to applying. Now if we're talking about analyzing, trying to get up to evaluating, creating, one of the things we've put into the 11th edition, we've changed the chapter 0, which is our analytical process. It used to be Tom Wenzel's students doing analysis of chocolate. Now this is the chapter 0 is about the distributed pharmaceutical analysis laboratory by Maria Lieberman. And if you're not familiar with that, it's a wonderful program. In that, an undergraduate student wearing the Notre Dame t-shirt was tasked with developing an analytical method for an antibiotic, where they then, once she proved she could do analysis in a reliable way, was given samples that had been collected by some of the pharmacists in Kenya to test if they were falsified or substandard. And so this was meant to be a way of getting students engaged into the idea of doing analysis. But what we've done is at the end of every chapter, we have what's called a choose your own adventure question, where in chapter 0, we ask students to choose an analyte in a sample that you want to figure out how to analyze over the course of this course. And then every chapter, students revisit that. Okay, we just talked about acid-base chemistry. How is that relevant to my sample? Is my sample got a functionality that might protonate, deprotonate? How does that affect my sample prep, my analysis? And so they're asked to reflect back on that particular case. And so you're trying to personalize their education or their learning. Okay, now let's move on to the second domain, the psychomotive domain. Now, again, simply put, often we think of cognitive domain as the lecture and the laboratory domain, or sorry, the psychomotive domain as the laboratory. And just like in the cognitive domain, Bloom's taxonomy has these different stages of learning or stages of understanding. Starts with observing, then duplicating, performing, adapting, originating. And so we'll try to talk about some of the strategies you can use to move up through those different. And personally, a lot of my feeling about how to develop the psychomotor domain came from our Quantitative Chemical Analysis 1 course at University of Alberta. We make no bones about this. This is a classic analytical course. And our rationale is not all courses can do everything. Particularly Quant 1, can really teach accuracy and precision and trueness. And so this is a really important opportunity. That's what we wanted to focus on. So how much did we focus on? Well, we've got all of these different experiments. That lab was worth 35%. We pulled some tricks to actually make it worth more without the students realizing. What students were told to hand in at the end of a lab is their ID number, their unknown number, and their result. And we asked for some analysis and precision. That wasn't graded. That was just for post-mortem sometimes when things went badly. Every unknown was unique. And we put a lot of effort into both making every unknown unique, but also to know exactly what their concentration was. A student got a mark, we marked out a 5 for very historical reasons. They had to, in some labs, the chloride by archmetric titration particularly, they had to be within 0.2% of the correct answer to get full marks. If they were 0.2 to 0.4% off, they got 4 out of 5, 80%. 0.4 to 0.8, 60%. If they were over 1% off, they were down to 40%, and we would take them, if they were over about 2% off in this case, we gave them 20% with the asterisk that they had to do a root cause analysis to figure out what went wrong. Now, there was some benefit to that in that we allowed students to redo one experiment at the end of term. So they really wanted to figure out what went wrong, and especially if they had 2 labs that failed, they could figure out what went wrong in one. That was the one they'd go for. So this was our context. And the first 2 weeks of the course was very intense in that we took students through teaching them how to use balances, teaching them how to use pipettes, teaching them how to read burettes. And then we did a lab practical test at the end of that, where we tested their ability to make a dilution. We tested their ability to read a burette. So that's the context, of course. In 2017, we introduced a number of lab-based videos. These were all short videos, usually under 4 minutes, on all the different operations that they had to do. And some of you may recognize some of these videos because a number of them were integrated into the 10th edition, and more so into the 11th. Now, what I found really interesting is because we did this lab practical test at the end of that 2 weeks, we could test how well students were at replicating or duplicating the procedures we wanted them to with and without these videos. And so if we take a look at the impact of the videos, and these are basic lab skills, so it's reading a burette and making an aliquot. So if we consider the burette reading grade first, these were all the years that prior to us introducing the videos. And so average scores were 70 to about 75%. With a little bit of concern because we seemed to be seeing a drop and we couldn't figure out why that was. This was the impact after we introduced the videos. Now, these videos were used within lecture, often in stop motion. And one of the things I would do if I had students looking at a video or me narrating a video on pipetting is I'd ask them to hold their pipette. That is, hold their pen. And okay, I talk about cocking the pipette. Well, I want you to cock your pen the same way. I want you to ground your pipette. So that's, again, remembering you're doing psychomotive learning. So you want to build up muscle memory. So these videos were very effective at helping the students with the burette reading. Likewise, when we looked at the aliquot preparation, we saw an enhanced improvement in the aliquot preparation. So this, when you think about it, if you try to explain to somebody how to ride a bike, it takes forever. If you can show them a video, it explains a lot more, and they're going to jump ahead in that. And so remembering psychomotive is very much this muscle-based behavior. And so getting them to see that in a few different ways, text, but also visual, helps different types of learners. Okay, so that's, okay, we've improved should say, one of the documents I put into the that Google Docs is a list of the videos that we've incorporated into the 11th edition. I think it's over 150 videos. Number of those videos that I just showed 2 slides ago are in that, but you'll find a lot of others. And just to give you an idea of the color coding, black would indicate videos that we have in the text. read are alternate videos that are similar topic, and a number of supplementary or additional topics. But videos can get a student up kind of duplicating, maybe performing, but we're not going to get up to that adapting and originating aspects of the Bloom's taxonomy and to psychomotive learning. So throughout the text, we try to show or put undergraduate research at the forefront, have it in there that students see it. It's in the text where we talk about Thompson River University students doing a particular experiment. We have it in the figure captions within the margin notes, trying to keep that at the forefront in the minds, hoping that the students will come to you and say, what's this undergraduate research? How can I get involved? And so hopefully open the door for you to get that type of opportunity to talk to your students, because that's where they'll start getting to those higher end originating, adapting aspects of Bloom's taxonomy, is really through that more sustained activity. Okay, so that's the cognitive domain, psychomotor domain, and we tend to think a lot about those. What we don't tend to think about as much is the affective domain. And here, this is often the attitude. So are students passive? Are they engaged? Are they valuing? Are they belonging? Are they becoming? And so that's moving up those cognitive domains within that affective. And so this is a lot of the revisions we've tried to do, is try to tap into that affective domain. And there's a really interesting study that was done a few years ago in education psychology, is the impact of what they call pro-social content. Now, pro-social would be how a topic or a concept can be used to help others or help communities. We'll contrast that with utility, how a topic or concept can be used or applied to humans. And so it's saying, hey, we can use this, but we don't emphasize the benefit to humanity, the benefit to people. And then there's neutral, which is just the facts. So we're not we're just saying, here's the facts. We're not trying to say how it can be applied either in general or to help benefit. So to give a bit more context, this particular paper talked about plant diversity. And so this is what they did is they took a 6-page chapter, and on one instant on each page, they had either a pro-social statement, a utility statement, or a neutral statement. And these were adjusted. All the rest of the content was the same. And frankly, all the testing that was done afterwards was on the content that was not changed. So in 4 cases, this was margin note. In 2 cases, it was within the general text. And so I've given some examples there where in the plant diversity, it talks about how different plants can help determine which ones will survive a drought and provide greater food supply. A neutral might talk about, hey, we can make better paper. A utility would talk about how we can make better paper. And then neutral just saying, here's the facts. So those are the 3. And as I say, 6 pages, 1 instant per page. And then they tested the students. They tested on a variety of things, their learning, their attitude towards the subject. And I'll focus more on the attitude. So that 1 modification per page, 6-page chapter, and then a test. So we have on the left side, the pro-social affordance belief. Can this subject help humanity? Can it help people? That's essentially the question. And what we see is pro-social versus utility is double asterisk, which means greater than 99% difference. Pro-social versus neutral is greater than 99.9%. So a remarkable enhancement in the belief that these students had that plant diversity was an important subject to understand because you can really help people with it. And I wouldn't have been able to tell you that prior to reading that paper. Now, also in topic interest, if we look at pro-social versus utility, we see there is a 95%, single asterisk is 95% difference. Likewise, pro-social versus neutral. Again, we've got a 95% difference in topic interest just from 6 snippets in a page or in a chapter. So this can have a powerful impact on students' attitude towards the subject. What I found interesting is if you look back at affordance belief, utility versus neutral. And I always thought, okay, if I tell students what this is good for, they'll be more interested or they'll think it's useful. No statistical, or not a 95% difference. I think it's on the order of a 40-50% difference, so not statistically significant. And topic interest even weaker. So that I still did use, and I still do use a lot of examples that are utility, but my belief in them is now skewing me towards, if I can I give a pro-social example? And so we really emphasize the revisions. We're talking about how analytical chemistry can help humanity in the environment, really, or serve humanity in the environment, because that seems to be what a lot of students can latch onto. And interestingly, it's a strong, in terms of affordance belief, importance of affordance, importance of helping humanity and people, is stronger in female students and is stronger in minority students. And so this is actually a useful strategy if we're trying to talk about helping first generation students or helping students that we want to bring into the field. Okay, so that's great. This of bringing in these pro-social examples is a way of bringing up students into valuing the subject. How can we do this? Well, a lot of different strategies that we have. One of them is case studies, and I'll talk briefly about that. The other is giving examples where analytical chemistry is serving humanity in the environment. We'll get to show students they belong and the opportunity to become a bit later, but we'll start with case studies and serving humanity. So here's 3 different repositories for case studies. Again, ASDL is my primary go-to, but I recommend all 3 different types of cases that you can find in each. So there's a little bit more details, I think, in the notes on this slide. I'll just leave you with that. One of the things I find, or I often hear when I talk about case studies to instructors, they say, where do I find the time? Like I'm already teaching the last half of my course in the last week. So how do you find the time? Well, the way you find the time is you wrap your subject around the case study, or rather wrap the case study around the subject. So I'll jump to the second, the misconduct at the lab. If you've used the 10th edition of the textbook, you'll be familiar with this case study because it's the opener of our chapter on on quality assurance and quality control. And the opener sets up a context where there's been there's a question of whether there's faked results in a forensics lab. And so throughout the discussion of quality assurance, quality control, through the chapter, we have different margin notes with different clues. And they all wrap back to this question of what's going on in this lab. Likewise, I mentioned the opener or the chapter 0 of the 11th edition is around the distributed pharmaceutical analysis laboratory. So that whole chapter 0 is wrapped around that idea of analysis of pharmaceuticals by a student. And then we use the choose your own adventure to bring that concept through the rest of the text. So it's not something extra you're teaching, but rather giving that teaching a context. Discussion of equilibria and activity. I think a lot of you are familiar with Paul Buckley and Eli Krug, and I just murdered his name. Beautiful case study on the Flint water crisis, which takes in a very complex equilibria system. And so again, we open up the chapter with that Flint water crisis saying why it was a real concern. And then throughout the discussion, essentially all we did is change a few equation or equilibria. Instead of just a chemistry example, we're giving a Flint water crisis equilibria example. And so we're just wrapping the discussion around the case, or the case around the discussion. So that's one way you can bring in case studies, bring in that affective domain without adding a significant amount of time to your lectures. I mentioned a second way, showing service to humanity and the environment. So openers talking about, electrochemical methods while we talk about wearable sensors. It's both, and also about continuous glucose monitoring. So students can see the benefit to humanity, but it's also something they can take home and, impress their parents with. Oh, I know how that glucose monitor that grandma's got on her upper arm works. You can also take simple analysis such as redox titrations. And one of the most effective public health initiatives in the history of the world is the iodization of salt. How do you analyze that? Redox titration, because it's a very simple analysis that even the hands of a non-expert can do pretty good results in a pretty low resource environment. Now, if you give it to a good analytical chemist, we can get really high accuracy as well. Cool. But regardless, it's a really worthwhile thing to know because this can really help humanity. Other examples, rather than just talking about, I like this radiopharmaceutical. If you're not familiar with theranostics, it's the idea that you put a radioisotope attached to some type of biorecognition element. And that biorecognition element, in this case, a hormone mimic, will bind to cancer tumors through a receptor. This radioisotope then could do two things. One, it can give off a positron or a gamma, so it allows you to tell where the cancer is. Well, once you know where the cancer is, and you know how big the tumors are, you can switch out and retreat the person with the same theranostic, but now loaded with a beta emitter or an alpha emitter. And because you're using the same hormone mimic, you know it's going to go to the exact same location and hit that tumor. So now you can go back and scan with a beta emitter or a positron emitter again and see how much did you shrink the tumor. What I love about this is you need a chelating agent, and there's characteristics of the chelating agent that are important. So this is like EDTA, but you also need a biomolecular chelation. So we can now, our EDTA titrations is now a discussion of analytical complexation, talking both about EDTA, but also now about immunoassays and ligand binding assays. So, because the math and the equilibrium calculations are the same. We could talk about point of need instrumentation, both classical colorimetric kits, but also then your modern paper microfluidics and screen printed electrodes. We can even talk about thermogravimetric analysis, but in the context of looking at carbon sequestration. So trying to bring in the analytical chemistry in our tools are serving humanity and the environment. Okay. So we're getting up there. Hopefully we got students from passive to engaged to valuing, hey, this analytical chemistry can save the world. Pretty good. How about belonging? Do students feel represented, and is there opportunities for them within the subject? So these are the people, maybe not all of them, that are featured within the 11th edition of the textbook. So this is throughout the textbook. There's short margin notes, or sometimes directly within boxes within the textbook, just talking a little bit about what they're doing and how they relate. And these are almost always people that are related directly to the subject material that we're talking about, sometimes in unexpected ways. But if you're not familiar with this paper, let me bring it up to you. This was a paper by Kate Reese and Zach Menzinger, where they developed a series of profiles of chemists. And there's a repository in Google Docs that's linked there, or Google folder that's linked there, which has profiles related to general chemistry, analytical chemistry, organic chemistry, radiochemistry, so wide array. And one of the things I found most powerful within that is they had developed PowerPoint slides. And so at that site, you'll find a series of PowerPoints, and one of them was drafted by me for analytical chemistry, and it's key to the 10th edition, very subtly highlighted in the corners of the slide. And what each of these has is talking about, as this one does, it introduces the person, where they're at, some of their research areas, and the bolded terms are always things that we talk about within the textbook that hopefully students or professors can highlight. And then the last is usually some of the different activities or awards that people have been getting. One of the reasons I think, or trying to think of how not to use the D word, but I'll say it. We want to think about the diversity of our students, and the people in the collection do reflect that, but in a variety of ways. People would look at Edgar and say, oh, he's Latin American. But do they see he's gay? Do they see he's first generation university? There's multifacets to the different people. Somebody like Dan Harris is profiled as well because he's colorblind. And this is something that 8% of the male students are going to be facing. And so it's nice for them to know that they can really succeed in analytical chemistry. Within those slides, if you go to the collection, you'll find, always in my PowerPoint, please look at the notes section, because in this case, there's a number where Edgar is mentioned in the textbook, but also some of the different resources that he's suggested that students might find useful. We're just in the process of developing a similar PowerPoint key to the 11th edition. And as you can see in the title, this revised slide is now People of Analytical Chemistry, because frankly, that's all it is people. Okay, so that's taking students from belonging. Can we bring them up to becoming? And this goes back, there's a variety of strategies again here. One I really believe in is undergraduate research. And others are, personally, I was a co-op student as an undergraduate, and that was transformative to me. I loved organic chemistry in lecture. I did 4 months doing organic chemistry in the lab, and I decided I was going to become an analytical chemist. So, so sometimes the transformation is not the way we want it, but at the same time, if a student discovers they don't like something, better they discover that early before you've got a massive university debt. Or alternatively, I got to do chromatography, gas chromatography as in my second work term. I was given, here's 3 GCs, make methods. That was awesome. Like, best experience I ever had, and ended up, my whole research career was doing chromatography. So it really can be transformative. So again, we try to bring up that, constantly. Every time there's an undergraduate researcher on one of our figures or one of our tables, it's going to be highlighted. It's in the index as well. So if you're looking for examples to show your students, just check that. I didn't put a slide in there, but there's a rule of 4 on propaganda, which is the first time you hear something, you're kind of skeptical. Second time it's repeated or you hear it again, yeah, I've heard that. Third time you hear it, you're kind of, yeah. By the 4th time, you're kind of course. So in terms of counter propaganda, you always have to intercept something prior to that 3rd repetition prior. We want to use that to our advantage. Keep reminding students, oh, there's undergraduate research, there's undergraduate research. We're not really throwing it at them hard, but after a while, they're going, oh, of course there is. So then try to get them involved. Part of that is we put it into those choose your own adventure problems. In chapter 2, tell them about information interviews. It's a really powerful technique for career development, career learning that isn't used very, it's really heavily used in business, but not very well used in science. And it's just a chance, you just ask somebody, what do you do on your regular day? Do you actually do titrations? Oh, you do, like, what's your pay? Do you get time off in summer? Yeah, whatever. you're just learning about the career. The second question that I've got there is just asking students now, think about undergrad research or co-op or internship. Again, trying to explore what opportunities are at your university. Throughout the text, not maybe as heavily as I'd hoped, we have examples or refer students to the ACS Careers and Chemical Sciences webpage. And Bavik, I believe the RSC has a similar page, and I think it's cited in the book, but I forgot to put on the slide, which just has information and sometimes, like vignettes about Sharon has. So, and it'll talk about what her job is, what her duties are, what are the companies like. So give students some idea about different careers. Like they know about forensic chemistry, forensic science because of CSI everywhere. But they don't often know about agricultural chemistry, food science. And so where chemistry and analytical chemistry can fit into all of those. So, so we've talked about the Bloom's taxonomy. I want to talk about one aspect that's not in Bloom's taxonomy, and I've tried to run this talk a bit short so we get a bit of chance to talk about all these and maybe engage in that last domain of Bloom, what should have been in Bloom's taxonomy, and that's the instructor. That's an integral part of the learning of the students. And if we think about instructors, especially in analytical chemistry, often you're isolated. A lot of instructors I know, they're the analytical division of their university. So they're isolated. That next level is you get colleagues. You can talk to somebody about, oh, you've taught this as well. How did you deal with this? Then you start building up networks. And finally, you get to a community. And I really want to thank Michelle and Bavik, because this lecture series is really working towards building that community. And I think that's going to be a massive effect on the learning of our students. So thank you so much for doing that. Let me just end with, when I say community, I really do view, and I know Dan does, that Quantitative Chemical Analysis, our textbook, is a community document. We really appreciate instructors telling us how they're using the book, strategies that they're using or resources they're using. I'm one of those weird people that loves to read syllabus because that gives me an idea on how instructors are working through the book. Because one of our goals is to keep the book current. And so that means we have to add something. But we will only add something if we can cut something. And so we have to have that counterbalancing cut. I love to know which end of chapter problems people use because I don't want to cut the ones you're using. So that's everything I've got. I'll maybe stop sharing now and welcome any questions or discussion.
Hello, Chuck. This is Dan Harris speaking.
Hi, Dan.
So first, thanks for letting me know about this webinar this morning. I found it when I started up my computer. I wanted to thank you for giving this talk and for pointing out what you do, what we've done together to try to incorporate as much real life instances in the textbook. So so first let me let everybody who's listening know Chuck is responsible for this textbook now. I've aged out of it after the 10th edition of Quantitative Chemical Analysis, and Chuck has 100% responsibility for how it goes forward. And if this webinar is any example, he puts an awful lot of effort and an awful lot of thought into it. And just incorporating the real world into the textbook does a lot to accomplish those learning objectives that you talked about today. So thank you.
Let me thank, on behalf of our community, Dan, thank you for 40 years of what you've done. Dan shared some data with me yesterday, I think. He's sold over almost 700,000 textbooks. That's the English edition. So he's easily in the millions in terms of how many people he's taught over his career. So quite incredible.
So I have a question, Chuck, and Dan. As educators, we are aiming for a holistic approach to teaching, right? So many of us do. And how do you think we should integrate AI tools, which now is very much in the works, to improve student understanding without losing the critical thinking and ethical awareness and, other aspects?
You've hit on one of the projects that I've got for the next year, if not longer, is trying to figure that out. I can't claim to have any really deep thoughts. And if you ask me subjects that we're still not gone deep enough in the textbook, chemometrics and AI is definitely one. Maybe in a year, I can give another seminar and give you an update. I actually have a colleague, one of my appointments is at University of Victoria, and we just hired a colleague that's a machine learning AI analytical chemist. So I'm really hoping to learn a lot from him. So sorry, no easy answer at this point.
I understand. Yeah, I'm struggling with it in all my classes. So I would have loved something to, from an expert like you. And Dan, I would have loved an answer.
Any thoughts you've got, please send, even if it's just the challenge, even if it's just the challenges, because that can really frame what we need to try to figure out how to get in there. But
Right.
it's definitely something we do need to think about. Okay, maybe I should have put in the plug for Macmillan. The AI tutor is actually ChatGPT type AI. So it's getting engaged or getting used right now within the homework system, but not directly within the analytical chemistry topic.
But as long as their teaching database or the tools database is good, then answers are correct. But many a times I've seen the answers to be very incorrect.
Again, please let me know.
Yeah. Okay, I will.
That's
no, I'm talking about the ChatGPT part, not.
Oh yeah. No, and now Macmillan trained the ChatGPT on our prompts that we had put into the homework problems. And what we're finding is essentially it's not that it has greater knowledge than our prompts. It's just students found they could defeat our prompts that, like, give me another clue, give me another clue. And eventually the classic system just, here's the answer. The AI is more patient, and so you're a little bit better on the Socratic method.
Thank you.
I just wanted to mention that I've used the homework with the AI tool this year, and it seems to be doing very well because I don't have many students coming in with questions, and when they do come to office hours, it's really questions that they were really stuck on. So, but some of my students actually told me that the AI has been very helpful guiding them towards the answers, and I prefer that, honestly, to Chegg or all these other websites where they have to pay.
Oh, that's lovely to hear. Anything we could do to damage Chegg, I'm all for.
Yeah.
Thank you. Michelle, would you maybe want to tell people about the discussion session?
Yeah, I'd love to. So I am the chair of a very active committee on education with the ACS Division of Analytical Chemistry. And about twice a year, the group hosts discussion hours for faculty and sometimes for students. So on May 16th, we're going to have a discussion hour And I think Chuck is going to moderate some discussion at the beginning with some folks who have recently done surveys of what students need to know in the analytical chemistry curriculum. So I saw Molly Atkinson put something in the chat. She did a great survey on what industry folks are looking for in recent grads for hiring. It's published in JChemEd. Jim Greenius is also going to be there. I worked with him and Trevor Smith at Rowan. The two of them did most of the work to do a survey through LCGC to look at similar things in terms of industry needs. But the idea will be to have a little bit of discussion with the panel at the beginning and then break out into rooms for conversation among the participants to talk to other analytical chemists who are actively teaching undergraduates and have some conversation about the topics that we're covering and the way we're covering them and the choices we're making about what to prioritize. I'm sure it will be a really great time, so I encourage people to come. We also have a library of videos of past discussion hours that I can share out into the chat.
Thanks, Michelle.
Yeah.
Bhavik, do you have anything about the May 30th talk to remind people?
Yeah, we've got a really exciting speaker from Scotland. It's gonna be a really interesting thought about how we consider bringing things outside of the classroom into more outreach arenas and encouraging more activities of analytical chemistry and thinking about the fundamental principles of analytical chemistry in terms of accurate measurement and trying to do that in an outreach space. So Patrick's spent a lot of time devoting his work towards sort of really interesting practices in branching out from higher education into further education and even lower education to try and encourage the principles of analytical chemistry mindsets at a young age.
Thanks, Bob.
So I want to thank everybody for being here, and thanks very much to Chuck for a great talk to kick this off. Everybody who's registered, I'll send out a link to the recording of this, as well as I've been collecting all the links that went into the chat. So Chuck's are in his talk, and I have the link to the resources that he put together to share, and then some of the additional ones about upcoming events or past events or resources through ACS or RSC. I'll also add. And if there's somebody on here from CSC who wants to send me some links by email, I'd be happy to add those as well, and I'll send them out to everybody. And we hope to see you again soon at one of these events. So thanks very much to everyone, and thanks, Chuck. That was fantastic.
Great.
Thanks, Michelle.
Have a great weekend, everyone.
Organizing.
Thank you.
And thanks,
Thank
Chuck.
you.